glycolysis, you go to either aerobic respiration in the presence of oxygen, or anaerobic respiration, which just means no oxygen, right? With the Krebs cycle and electron transport chain in the end, okay? So let's first start with glycolysis, okay? So glycolysis is going to be your first step of cellular respiration, right? So before even starting, what do you guys know or want to guess about glycolysis? Someone just toss something out. Anything that you can think of that comes to mind with the word glycolysis. Sugar, right? Glucose, okay? So, so everyone does glycolysis, okay? Glycolysis is what anaerobic organisms and aerobic organisms, okay? So someone want to tell me what an aerobic organism is? Yeah, Robert?
Someone that does cellular respiration instead of something that needs oxygen.
Right, so they use oxygen, aerobic, okay? Anaerobic organisms don't use oxygen. And so you have two different types of anaerobic organisms. You have facultative anaerobes, so facultative, and you have obligate anaerobes, okay? So obligate means they are obliged. They have to have no oxygen. So they're an obligate anaerobe, okay? Anaerobe. Okay, a facultative anaerobe is going to be an organism that can use cellular respiration with oxygen and without oxygen, okay? So they are facultative. They can function in both situations. I think that's the proper spelling. Look it up maybe. A-N-A-E-R-O-B-E, right? You'll recognize it when you see it. So obligate and facultative are the two main things to get from that, okay? Obligate is what? Marshall. What is an obligate anaerobe?
You cannot have oxygen.
Right, you absolutely cannot use oxygen. What is a facultative anaerobe? You can or can't. It doesn't matter either way. You can function in both situations. Right. So those are just two things to keep in mind. All right. So with glycolysis, you start off with a glucose molecule. All right. So glucose is how many carbons is sugar? How many carbons are in glucose? 6, right? 6 carbon sugar. So let's move this away. Linear subside. Hope you guys got that. We'll write it down at the end maybe. Okay. So glucose is a 6 carbon sugar. Okay. Why is it a sugar? How do we know it's a sugar? Yeah. It's a carbohydrate, right? So carbohydrates are sugars. Okay. Yeah. What? Glucose. Os. Yeah, and os, right? That indicates it's a sugar. Glucose, maltose, fructose, any one of those. Well, anything that ends in os is typically going to be a sugar, okay? All right, so with glycolysis, you start off with one glucose molecule, okay? So one glucose molecule is a 6 carbon sugar, right? And we go to 2 pyruvate molecules, right? So if we go from a 6 carbon sugar to 2 other molecules, how many carbons do you think are going to be in each of these, assuming we have an equal split?
Attention, will Jeffrey McGinney
3,
please
right.
report to room 126? Jeffrey McGinney to room 126. Thank
So
you.
you can safely assume that your pyruvate is going to be a 3 carbon sugar. And so they may even ask, like, which of the following is going to be a 3 carbon sugar? And you'll see like a pyruvate molecule, like, yeah, it's pyruvate, okay? So that's that. In glycolysis, you have glucose converting to 2 pyruvate molecules, 1 3 carbon, 1 3 carbon, right? And you have some input of NAD+. Okay, so this gets really confusing, okay? You have to keep track of these, like, I still get confused with them. You have to pay attention to them, okay? So, with glycolysis, here's your equation, okay? I'll write this down and then it's up there as well, okay? So, glucose is going to be C6H12O6, right? Your input. Plus, you're going to have 2 ATP that you need for glucose. Okay, so someone tell me why we need ATP for glucose if we're trying to make ATP. Okay, so the reason we need ATP is because we can't have glucose or glycolysis even happen if we don't have some sort of source of energy, right? Yeah. No, I said ATP. Yeah. So we need ATP because we have to have some sort of input of energy to do this whole process of glycolysis, right? So plus 2 ATP. Okay. Now we also have energy in the form of NAD+. Okay. So we have 2 NAD+. Someone tell me what plus means on the NAD. Robert.
I'm not sure, but
So it's going to be positively charged, okay? So, yeah, Shazib.
What's the D in NAD?
So don't worry, but this is going to be actually a chemical name, right? It'll be a name. So don't worry about for our purposes,
This
you
is
don't,
just shorthand.
yeah, you don't need to know. It's an abbreviation. These aren't elements, by the way. This is just NAD, the molecule, and it's positively charged. Okay. So yeah, people confuse that. All right. So we have this glucose plus 2 ATP plus 2 NAD plus yields. First, what do you know that glucose turns into? Two what? Pyruvates, right? 2 pyruvates. It yields 2 pyruvate. I'm just going to pyruvate right now because there's no sense in writing the entire chemical structure. Plus 4 ATP. Okay, so we gain 4 ATP from going into glycolysis. Plus 4 ATP. Plus 2 NADH. All right. So this is important right here. We have NAD plus and we get NADH. Okay. So we added a hydrogen ion to it. All right. Yeah. And then,
You went a little fast on the backtrack to explain why you get 4 ATP because it's gained in glycolysis.
that's fine. Yeah. Okay. So all right. We'll go back to that. Okay. So during glycolysis, this is where you have to really pay attention to. Okay. So we use 2 ATP, right? And we also yield 4 ATP, right? With it right there. So tell me how much net ATP we gain. 2, right? 2. 4 minus 2 is 2. So sometimes you'll see they'll ask, what is a net ATP produced in glycolysis, and what's your answer? 2. What if they ask you how much ATP is produced from glycolysis? 4. See, that's where it gets confusing. Okay, you have to account that you have 4 produced, but 2 are consumed. Okay, so a net of 2. All right, we can effectively cancel these out to make that go away and turn that into 2 ATP. The reason I didn't do that is because I wanted to emphasize the fact that 2 ATP are used into consumption. Okay, so those are consumed. All right, so glycolysis occurs in the cytoplasm. You'll often have questions that say, where does glycolysis occur? Where does the Krebs cycle occur? Where does oxidative phosphorylation occur, right? So you just need to know the location. So it occurs in the cytoplasm. So what is the cytoplasm, by the way?
It's the gel-like substance in the cell.
Exactly. So you have, it's like a fluid-like substance that's going to be permeating through your cell, right? It's just going to, you'll have organelles floating in your cytoplasm, all right? So not just cytoplasm. So far we have, who does glucose? Tell me what kind of molecules, what kind of cells do glucose, or not glucose, glycolysis, all right? What kind of cells undergo glycolysis? All cells, right? All cells can undergo glycolysis. Okay, so what does one glucose, I probably should cover this up. All right, so what does one glucose yield in glycolysis? Don't look at the board. Yeah, so the glucose itself is converted to what? 2 pyruvates, right? 2 pyruvate molecules.
Attention,
Right.
will Red
How many
Enterline
carbon,
please come to the
sugar-
main office? Red
How-
Enterline, please come to the main office.
How many carbons does pyruvate have? 3. How do you know that? Right, 3 times 2 is 6, right? Okay. What is a net production of ATP in glycolysis? 2. And how many ATP molecules are consumed in glycolysis?
2.
And how many are produced? 4. Right. Where does glycolysis occur? Cytoplasm. Okay, so now I will erase. So you guys have this down?
Yeah.
Okay. So what does the positive charge on NAD plus mean? Right, it's positively charged, right? Okay. And what does NADH mean?
It's a molecule.
It's like NAD plus, but with the hydrogen molecule, right? Or hydrogen atom on it. Okay, right? Okay. And let's see. Glucose. Okay, so now keep that in mind, right? Because this is about to get even more confusing than this. That was the easy stuff. All right. So let's keep a running list of our molecules right now. So someone tell me a molecule involving glycolysis. Glucose. We have glucose, right? What else do we have? Someone tell me another molecule. Pyruvate. Another? ATP. NAD plus and NADH, right? Okay, is that all? For glycolysis? Yeah, that's all. Right? Glucose and pyruvates.
He always.
ATP goes to ATP, right? ATP is produced. NAD plus NADH. Good. Okay. So let's go on to aerobic respiration. So what is aerobic respiration? What do we know just in the title itself? We need oxygen, right? The organism or a cell undergoing aerobic respiration is going to be Aerobe. Aerobe. Just an aerobe. Aerobic cell, aerobic organism, whatever, right? So, okay. So, we have oxidative metabolism, okay? So, that's going to tell you that a max total of 38 ATP is produced in aerobic respiration, okay? Our net is going to be 36, all right? Someone tell me why our net is going to be 36 based on what you already learned. Shazib.
Because you use 2 during glycolysis.
Exactly, used to during glycolysis. So these are tricky questions. Trust me, you'll see the numbers 38, 36, 34, 32 all around when you talk about cell respiration, and you won't know what number to choose. Okay, so watch out for net and just regular production. Raw production and net production are different things, right? Okay, so our pyruvate is oxidized down to CO2 in the Krebs cycle, okay? So, someone tell me what CO2 is, how many carbon sugar is that? Or how many carbon molecules is that? 1 carbon, right? Pyruvate is a 3 carbon, right? Keep that in mind. Okay? So you have NADH and FADH2. They create a pH gradient by pumping hydrogen ions out of mitochondria. Okay, so you have your. I am bad drawing mitochondria, but essentially that's going to be your mitochondria, right? What? Yeah. So essentially it's your mitochondria, right? What? Yeah. Okay,
label it
so for
mitochondria.
our purposes, this is mitochondria, all right?
Can you draw that better?
No, you don't need to worry about the drawing right now. You just need to worry about what's happening, okay? We'll go into that later on in the organelles. Okay, so your mitochondria. So you have, so far we talked about these molecules, right? For glycolysis? Yeah. So that's glycolysis. Have we encountered any new molecules yet? We have NADH, right? We already talked about that. And FADH2, okay? So let's put in FADH.
This is another one.
2 right here, okay? So what is pH again? Someone let me know pH is. Yo, hey, guys over there, pH, what's pH?
Oh, it's the
Right.
temperature.
So Marshall said it right. It's a measure of how acidic or how basic something is, right? So pH is going to be a scale, a measurement. So right here, earlier on we talked about, or maybe we did talk about it, what is going to essentially cause something to be acidic or basic? Hydrogen ions are going to cause something to be what? Acidic or basic? Acidic, right? And hydroxide ions are going to cause something to be
Basic.
right. So right here we're saying that we have NADH, right, and FADH2, and they create a pH gradient by pumping hydrogen ions out of the mitochondria, right? So here's your mitochondria, and hydrogen ions being pumped out of it, right? So H plus ions. So a gradient is any sort of thing that has a variance in concentration, okay? So it could be a gradient of charge, it could be a gradient of acidity, it could be a gradient of, I don't know, like non-polar molecules, or something, you know? Or polar molecules. It smells burnt. Okay. So,
No, this was just. This,
I took the kernels and
I
then
took the
popped
leftover
them.
kernel and tried to pop them again.
no. Alright. Anyway, so we have a pH gradient
Did
right
you say
here.
oh or no?
No. No. Alright, so, okay, so we have a pH gradient right here, right? So the differences in concentration, you don't need to worry about the specifics of this right here, but essentially the differences in concentration of the hydrogen ion, so the differences in acidity, is what's going to cause your ATP synthase to go, your synthesis of ATP, okay? So production of ATP is going to be a result of your change in concentration, right? So things are going to be pushed to balance out the concentration gradient, and as a result, you'll have a production of ATP, right? So we won't talk about the specifics of that just because you'll get bogged down in those details, and it's kind of confusing and not entirely relevant right now, okay? So, let's talk about, okay, so let's do the Krebs cycle, okay? So, pyruvate produced in the cytoplasm moves through both mitochondrial membranes to the interior of the mitochondria, okay? So, what that means is, so what happens at the end of glycolysis? What are your products?
36.
No. Glycolysis, just glycolysis. 4 ATP, right? 2 net ATP, right? 2 pyruvate molecules. What else?